Hello guys, welcome everyone. In the last previous videos, we have seen about the problems on Lem's theorem and its applications with various examples. Now we are going to see about resolution of forces. So what do you mean by resolution of forces? It is very similar to Lem's theorem problem, but the only difference is Lem's theorem problem only focus with three coplanar forces. If the existing system of forces consisting of number of forces more than 3, we can consider resolution of forces. For example, we can have the example for this video. Find the question. Find the resultant of forces from the following equilibrium of forces as shown in the diagram. So this is the diagram part they have given in the problem. In this problem, they have given 300 Newton, 400 Newton, 350 Newton and 200 Newton. We have 4 equilibrium system of forces which is more than 3. That is not coming under Lem's theory problem. So we can definitely apply from resolution of forces concept. Okay. The 4 forces, right? We have 1, 2, 3, 4. 4 type of forces. They have various different type of angular distances like 30 degree, 40 degree, 60 degree and 20 degree, right? So we have to find the resultant force. So what do you mean by the resultant force? The sum of forces acting in multiple directions, right? So it must be joined as a single line. It must be joined as a equilibrium line that denotes the overall force, that denotes the overall force and direction. That is called as resultant. So how to find the value of resultant means the formula for resultant is summation of square root of summation f of x square plus summation f of y square. So how to find the value of summation f of x and summation f of y? For that we have the following table that explains the overall concept in this video. One more time I need to tell you about this. By referring various amount of books, by referring various form of the books, this method, this table has been formulated by our faculty of Department of Mechanical Engineering. So this concept of explaining the resolution of forces is new to our syllabus and it is very easy one. Okay, you cannot skip even a 4 to 5 seconds itself because it's very important. You cannot skip over that. So please watch the video completely without skipping. So let me go to the parts. So how to split all those things? I need to check because in the Lem's type problem, what you have said, we have separated into 2 blocks or even 3 blocks or even 4 blocks, right? In this type of resolution of forces problem, we cannot go in type of a separate block, but in terms we can go as a part by part diagram. So what do you mean by a part diagram? Let me explain you. Regarding the first force, it is acting in this direction with 30 degree from first quadrant. So this is first quadrant where the x-axis is positive and y-axis is also positive, right? So the angular distance is like that. So that is why I am telling how I have found this is like an L. This is having positive x-axis and positive y-axis with 300 Newton covering 30 degree. So coming to the second quadrant. The second quadrant comprises of x-axis is in negative direction, y-axis in positive direction. The force is 400 and the degree is 40. That is why we have 40 as it is. As it is, x-axis negative, y-axis positive. Regarding the third quadrant, the force 350 Newton acting in x-axis negative, y-axis negative. That is why x-axis negative, y-axis negative, and the degree is like that. And then the fourth quadrant, x-axis positive, y-axis negative. That is why we have separated the diagram into 4 equal parts. Why 4, sir? Because we have 4 equal number of forces. That is why we are splitting into 4 types. Why it means, if it is 5 means, we can split the part diagram into 5 equal parts. If it is 6 means, we have to separate it into 6 equal parts. Okay. So the first one is serial number. How many forces are available? So that is the main thing. Number 1, 2, 3 and 4. 4 type of forces available. After that, the part diagram will be 1, 2, 3 and 4. 4 forces available. Okay. So let me go to f of x, summation f of x and summation f of y. How to solve all these things? Is that okay? Okay then. Okay. So regarding f of x, it is nothing but the force 300 Newton is acting in with reference to x-axis. With reference to x-axis means the value of f of x will be equal to 300 into cos 30. Why we have to add cos 30, sir? If it is not sin 30 or tan 30 or cot 30, everything available, why we are especially placing cos? Because the degree is with reference to x-axis. That is why we are getting cos. Okay. For in terms of f of y, considering y direction, the degree is not concerned. The force is not concerned with what? X-axis. It is not concerned with y-axis. It is focused only with the x-axis. That is why the degree is not touching the y-axis. So it is multiplied with sin 30. For example, if the 30 degree is there, I need to give you an example. If it is not 30 degree, it is actually 60. With reference to y-axis means how could we solve it? We can solve it very simple because this 300 is touching with reference to y-axis, not x-axis. So how will you solve? We will solve the f of x value will be, it is in touch with y-axis. So the value will be 300 sin 30, and for f of y we will set sin 60. Sin 60. For f of y, what we will do? It is equal to 300 cos 60. So by referring those steps, you can understand when the degree is reference with x-axis, the resulting value will be cos. The resulting angle we have to take with cos. If the degree is taking reference with y-axis, you have to take cos in f of y. Okay, so let me go to the problem again. This is just an example. Let me not pollute the problem. So we'll go with the as per regular condition. This is actually 30. Okay. Following the next step, this quadrant is having degree reference with x-axis. So already the value of x-axis is negative. So you have to take minus. The value of force is 400. The degree is reference with x-axis. So cos 30, you have to put cos 30. And then considering y-axis is positive. The axis is not, degree is not reference with y. So we can put 400 sin 40. Okay. Regarding the third step, we have x is also negative, y is also negative. So first of all put negative symbol there because in place of any mistake, in place of any careless mistake, we have avoided minus or negative because negative means it will go to a very large deviation in answer that would cause a very deviated answer. It will gives you reduced marks. So that is very important. Negative symbols must be put as per order, as per the graph positions. Okay, then the 350 degree mm, this 350 Newton force. Right. This is the degree is touching with reference to x-axis. So we can put cos 60. Likewise, y-axis doesn't touch with the angle. So we put sin 60. Okay. The next step, the final quadrant, the x-axis is positive and the y-axis is actually negative. So what you have to put? Okay, regarding the fourth quadrant, the x is in positive direction, y-axis is in negative direction. That is why we are using positive symbol and here negative symbol, right? Like we said earlier, here the degree is in reference with y-axis, not x-axis. So in terms of x, there is no contact with the x-axis, though we have to use sine. Okay, but the degree is in reference with y-axis, so you have to put, definitely you have to put cos 20. So while referring all those values, you could see here cos, but this value alone differs with sine. Why? Because in all those given degrees, the angle degree is reference with x-axis means the value of f will have cos. If the value of degree not touching the, with not reference with the x-axis means you have to put sine. Okay. Then the opposite direction, this is minus 200. The axis, the angular distance is in reference with y-axis. So you have to put cos. So that is why we are using minus 200 cos 20. So the values are given. The formulated values are for the first part f of x 260, f of y 150. Here minus 346, here 257, here minus 175, here minus 303, here 68, here minus 188. As per the given values, we have 260 and 68 are positive, minus 346 and minus 175 are negative values. We have to sum all those values, we will get minus 193 Newton. Likewise, here 150, 257, both positive values, 303, 180 negative values. We have to sum those things and subtract with them. We will get minus 84 Newton. So for the formula for resultant, we have told you already, the value of R which is equal to square root of summation f of x square, summation f of y square. The values are given as minus 193 square, minus 84 square, because we have been solved the values of f of x and f of y. Then we give the value mean 37249. This expansion 7056. While square all those things mean we get 210 Newton. We have 210 Newton. So what do you mean by the direction? So the value of force we have find, the value of resultant we have find. The direction, what the direction means? We have 4 number of forces, right? Each having each degree. Then where will the resultant force, where will the total force will go? That is called as direction. For that we need to find theta equal to cos inverse of summation f of y divided by summation f of x. We have to divide the value of f of y divided by f of x. Putting the values 84 by 193 minus will cancel. The overall degree will be 64. So the result must be written like this. The resultant of forces R which is equal to 210 Newton. The direction theta will be equal to 64 degrees. The sum doesn't end here because the primary thing will continue after this step. Because what do you mean? What they have been given? The resultant is 210. Okay. The degree is 64. The degree is 64 means we have to put it in the positive direction, and from this the value is 210 and the degree is actually 64 degrees. Why it is coming in first quadrant? Does it come in second, third or fourth or anything? That is not an issue. If the degree, for example, if the theta value comes around 130 means where will you plot the graph? It is the starting point, origin of the curve. It is 0. After that, here 90. After that, with 30 degree reference, we will take the value. So depending upon the theta value given, we have to plot the final diagram like this. So if we start the diagram with like this, and we have to end the diagram like this. So this problem oftenly asked in university problems, and then force in space problem with the application of vector algebra is another important topic in this section. So force in spaces problems will be continued in the upcoming videos. So please like the content, share the content. For any queries, please comment below. Thank you.